Hello, this is Mr. Boughton here. I'm going to talk to you about calculating the area of some simple shapes. There's three simple shapes here we're going to look at, and I'm going to talk to you a little bit about area and then how to figure out the area of these. There's a lot of real-world context to it, so it's good to know how to find area, be familiar with that, just kind of in real life. By the way, you want to take notes on this, so please open up your notebooks to a fresh, clean page. Get your pencil out. This is your title right here. So write your title in here. Area is flat space, so I just kind of included that in there. Write that at the top really big, very neatly, and then along the side, the length of your paper. Like the first part will be rectangle, put that near the top, and then kind of scoot down to the middle of your page. Write parallelogram, we're going to be looking at those. A rhombus is also a type of parallelogram. And so put that in the middle of your page and then kind of go down a little bit further and then put triangle. Write those really big. Like these are going to be large subheadings on your page, and you can use this page to help you throughout this unit. Your notes are important for another reason. It's because your brain will remember what your hands do. They remember what they see a little bit, they remember what they hear a little bit, and they also remember what your hands do. So if you do all three of these things, like you're hearing my voice, you're seeing me work it on here, and your hands are writing it out as well, your brain really is remembering this the best way it possibly can. So pause this video for a second and then write out the title right here, and then these three shapes: rectangle, parallelogram, rhombus, and triangle right there. Okay, pause here and go. Okay, now you're back. Let's talk about how to calculate these. Now these are what I call the simple shapes because they have a simple formula. It's very easy. You just kind of use that formula, calculate it, put it in your calculator, and then you've got your answer. So when we calculate area, I just kind of want to go back to this basics. Area is a flat space. Think of carpet, it's flat. Think of paint on a wall, flat. You know, whiteboards are flat, ceilings are flat, anything that's flat, a tabletop. So when you cover that, that is area. And there's a lot of real-world applications to this, like if you own your home. So what I did, I just went to a website right here that you'll be familiar with because it's going to be part of a kind of a fun project where you design your own yard. And but in real world, if you own a home and you have a yard, you kind of need to know the square feet of your yard or even your house. Or any part of your property, because you may want to do something like cover it with grass seed or cover it with, you know, fertilizer or something. I don't know. You buy stuff at Home Depot to cover your lawn, but you need to know the square feet, which is area. And so if you think of this rectangle right here, you would simply measure the length of your lawn right here, which is 16.7 meters, and the width of your lawn right here, which is 7.35. And you would multiply the length times the width, and that's the area of your lawn. So when you go to Home Depot and you say, I need grass seed, and they're going to say, well, how big is your lawn? You know, what's the area of your lawn? You'll know what to tell them, and they'll give you the right amount. So calculating a rectangle is something we have already done. You've done that plenty of times. It is the length times the width. And you are counting, basically what you're doing is counting the squares that will fit in that. So let's go back to our lawn. You can see there's a grid back here, and this grid, each of these squares that you see back here is 1 meter in length according to our key down here. Each grid level here is 1 meter. So when we measure these, this is a straight line, one dimension is the length, and the other dimension at a 90-degree angle here is the width, and it is covered in that many squares. So when we give the Home Depot guy there our area, we're saying this is how many square meters fill, or I should say cover, our lawn right here. So we're kind of just counting the squares inside of a rectangle that we can't really see the squares, but that's how many square inches would fit inside here. And this would be the length times the width would be 88.4 square inches. We're able to fit that many little squares in there. So go ahead and copy this down. You're going to write down, just kind of draw out a shape so you see, okay, that's a rectangle, and this is an example right here. And this is the formula. So make sure you're putting a box around that formula So you say, okay, I've got to know length times width. There's our rectangle formula right there. Okay, let's go down to parallelograms here. Typically, parallelograms look like this. All right, so they kind of have this shape. Now, parallelogram can look differently. In fact, a parallelogram, the word parallelogram, is a kind of a broader term. In fact, a rectangle is actually a type of parallelogram. All a parallelogram is opposite sides are parallel, right? That's a rectangle. These opposite sides are parallel. These opposite sides are parallel. So a rectangle, squares, those are all parallelograms. A rhombus is a parallelogram. And so, but typically when we say parallelogram, we're kind of thinking about at least this type of shape. Looks like a rectangle, like leaning over, about to fall over. And so we have what we call the base, which would be the length. You know, we use the term length in a rectangle, but we just, for some reason, I don't know, we use the word base for a parallelogram, and this is the height. Notice that the height is at a 90-degree angle to the base, right? This is like a letter T, all right? Now, the opposite sides are parallel and they're congruent, all right? They're the same length, so this could be the base right here as well, all right? And this is what we call the slant height. It comes at an angle, so this is not the other dimension. If base is a dimension, slant height, we do not use it because it's not at a 90-degree angle to the base. So how do we find the area of a parallelogram? How do we count these little squares if they're not like whole squares? They're really too hard to count. Well, imagine cutting this right like this and then and moving it over here like this. Now what shape did we just make? A rectangle, right? And so we need to find our area. Well, we're asked to find the area, but we don't have the numbers in place. But we do have the grid. And so when using a grid, we want to count the lines along the base. So from this point here to this point here. Now we're not counting boxes, okay? Don't count boxes or anything because we're not going to be able to see it like this. If we see this, like we might say, well, that's not a full box. How do I count that box? We're not counting boxes. We're counting the lines from here to here along the base. So from here to here, all right, that's 1, 2, 3, 4, 5, 6. So the base is 6. Okay, that's where I got it over here. So the base is 6, and the height is going to be 1, 2, 3. So the height is 3, and the base is 6. And so if we look at it this way, really we're just taking the base times the height. It's the same as a rectangle, but we just use base and height instead of length and width. All right, so we use 6 and 3, multiply those, and that's our area right there. So take your pen, like write all of this down, these notes, and just box that in. That is our key, that is our formula for all parallelograms. All right, now did we use the slant height? Because I will give you a number here. I'll put something in. I'll say, oh, it's 3.4. You'll see numbers in place, but do you have to use every single number you see in here? No, you don't. And so the slant height, we do not use that for area. You would use it for perimeter because you have to count all the edges for perimeter, but not for area. So we ignore this. Don't do anything with it. So there's parallelogram. Go ahead and pause and catch up here. Write all this down. Make sure you have it. Now let's look at the triangle. There we go. Let's take a look at this triangle here. I'll just move this out of our way. So how do we find the area of our triangle? Get rid of that. Well, we have a base, we have a height. Notice the height is 90-degree angle. We draw kind of this little square shape to show that this is a 90-degree angle to the base. So that means we're not going to use this side number. We're not going to use this edge. We need one of the edges as the base, but the other is a straight line from the point straight down to the base in a 90-degree angle. So that's what we're going to use for our base and our height right here. Let's get rid of that. Base and height, let's put some numbers down for this, okay? Let's just say the base was 10 inches and the height was 5 inches, okay? Go ahead and write that on your page. Just anything I do on here, like I'll let you know, these are good notes to have. Let's put our numbers in place so you can write those down as well. By the way, this is not complete over here, so don't just say, oh, I got it. I'm going to write that down and move forward. That's not complete. So how do we find all the squares that fill in a triangle using just the base and the height numbers? Well, imagine we had two triangles, two identical triangles, and we turned one of them upside down here, and we moved it along the side of this like this. What type of shape do we have here? Yes, it's a parallelogram. That's right. And a parallelogram is found by doing base times height, 10 times 5. Right? So our parallelogram that you're looking at is 50 square inches. But we don't want to know two triangles. We just want to know one triangle. So what do we have to do to our 50 or our formula to say, I just want one triangle, not two? So if you're thinking, I want to divide it by 2, you're right. We just divide it by 2. Also, we could just say, I'm going to take half of it, which means we're going to multiply by half. So when I write the formula, you'll see 1/2 times the base times the height. Or you'll also see written this way. Now, generally, I don't write it this way, but you'll see it as well. Base times height divided by 2. Base times height divided by 2. So both of these are formulas that they say the same exact thing. So let's do this. We have 1/2 times 5 times 10. Now when you multiply by half, you're just dividing by 2. Remember, reciprocals. They are the same things. So we've got 3 numbers to multiply. Remember, you can multiply in any order. You could do 5 times 10 is 50. And then what's half of 50? So half times 50 is 25. Or you could do you can kind of shuffle these around a little bit, use the commutative property and say, well, let's do half of 10 first. I could just do that in my head. That's easy. That's 5. And then 5 times 5 is 25 as well. So either way, I don't know what happened there. Either way, we end up getting 25 square inches. 25 square inches. So don't forget your units. Always have your units, because you will have points deducted. You just always want to make sure your units are in there too. So 25 square inches. So we have learned how to find the area of a triangle by using this formula. Make sure you box it in, make it very clear on your notes. This is the formula right here. Don't forget the 1/2. This 1/2 on a triangle is what will cost a lot of points. I've seen so many really smart kids not do well on a test because they kind of rush through and they don't do the 1/2 for a triangle, and they get those problems wrong. So remember the 1/2. We've also learned how to find the area of a parallelogram and a rhombus. A rhombus is just a parallelogram where the 4 sides are the same length. And we find the area of a parallelogram simply by multiplying the base times the height. And we don't do anything with the slant height. We just pretend it's not even there. And the area, of course, of a rectangle, we reviewed that by doing length times width. So these are the simple shapes, and now you're just going to practice doing some problems, finding the area of simple shapes. Thank you.